Something terrifying happened at exactly 2:38 p.m. Eastern Time. Satellites started behaving strangely. Navigation signals flickered. Engineers monitoring power grids started preparing emergency procedures. And then, in parts of the world, the sky turned glowing green. But here's the part nobody expected. This wasn't a cyber attack. It wasn't a secret weapon test. It wasn't even caused by anything on Earth. It started almost 93 million miles away, when the sun decided to remind us who really runs this solar system. And what happened next shocked scientists around the world. The moment the solar shockwave hit Earth, our planet's magnetic shield compressed like it had been punched. Spacecraft in orbit suddenly faced increased atmospheric drag. Radio signals weakened. GPS accuracy dropped in certain regions. This is because storms from the sun don't just create pretty lights in the sky. They push massive amounts of charged particles into Earth's magnetic field. That energy can create electric currents inside power lines, pipelines, and satellites. And history proves how dangerous that can be. But this story actually began days earlier, on the surface of the sun itself. On January 18th, 2026, scientists detected an X-class solar flare erupting from the sunday. These are the strongest solar explosions we classify. To understand how powerful that is, imagine energy equal to billions of nuclear bombs releasing at once. This flare launched a massive cloud of plasma, called a coronal mass ejection, directly toward Earth at incredible speed. And unlike most solar eruptions, this one arrived extremely fast, reaching Earth in about a day. But what really scared scientists wasn't just the flare. It was what followed. By January 19th, Earth was hit by a severe S4 solar radiation storm. That level is extremely rare. In fact, storms this strong haven't been seen since the famous 2003 solar storms. These radiation storms can increase danger for astronauts, disrupt satellites, and interfere with high-frequency communications used in aviation. At its peak, the particle radiation levels became some of the highest ever recorded in modern satellite history. And that's when auroras exploded across the planet, appearing far south of where they normally exist. And maybe the most important thing this event showed us is how small we really are. For decades, humanity has built systems thinking we were in control, satellites guiding planes across oceans, GPS helping billions of people move through daily life, power grids connecting entire continents like one giant machine. It all feels permanent, untouchable, stable. But in less than 24 hours, a storm from a star 93 million miles away reminded us how fragile all of that really is. And the truth is, this wasn't the worst-case scenario. This was a warning shot, because the sun is entering one of its most active periods in years. More eruptions will happen, more storms will come, and someday one might be stronger than anything modern civilization has ever experienced. That doesn't mean panic. It means preparation. It means understanding that Earth is part of something much bigger, a living, moving cosmic system that never truly sleeps. And maybe that's the most fascinating part of all. Every time you use your phone, every time you follow GPS, every time lights turn on in your home, you're depending on technology that exists under the constant influence of a star powerful enough to wipe it out in hours. So, the real question isn't if another major solar storm will happen. It's when, and when that day comes, will we be ready? Because space doesn't care about borders. It doesn't care about technology. And it definitely doesn't wait for us to catch up. The sky above us isn't empty. It's alive. And it's watching. And the sun is still in charge.